Hi, welcome to Essential IT and Security Skills. I'm Charles Redmond, Master Trainer, here to guide you through the essentials that you are going to need to land the job that you are looking for. In this series, we're going to talk about essential PC skills. I'm going to walk you through everything from software to hardware. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series with some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here, the essential PC skills. We'll discuss network ports, LANs, and WANs. So at the base, or at its heart, what makes the internet work, it's surrounded by protocols. Network protocols take care of addressing and security, as well as many other functions. Those protocols are combined into groups called protocol stacks. Understand where we are today is a migration of where we came from. It all started in the mid-1980s when IBM developed the NetBIOS Extended User Interface, or NetBEUI. It was the default protocol for the early versions of Windows. The underlying protocol stack was called NetBIOS NetBEUI. Now, this protocol stack was great for small networks, but it relied on individual computers to send out frames addressing to the MAC address. We call this a broadcast. Again, very good for small networks, but large networks all needing to send out constant broadcasts was overwhelming for most larger networks, eating up a lot of bandwidth, and bandwidth costs money. So these networks, small or large, we break them up by size. The smallest of them usually being indicated as a local area network, or a LAN. It's a group of computers that are close to each other. It's almost always a group of computers that are able to hear each other from where one of them sends the broadcasts. A group of computers, a LAN, that are connected by one or more switches is identified as a broadcast domain. Next, we have wide area networks, WANs. It's a large spread groups of computers, large spread groups of LANs connected using long distance technologies. WANs are typically connected via one or more routers. The LANs are broadcasting to send frames to their computers on the network, but the bigger the network, the more bandwidth is taken up by all this massive broadcasting, and routers don't forward broadcasts. So a different addressing method was needed. The NetBIOS NetBEUI stack was great for a single LAN, but because it is a broadcast-based protocol, it was not able to function across routers. So enter the TCPIP stack. It's a suite of network protocols that was invented in 1983 that quickly became the de facto protocol suite for any computer connecting to the internet. In a TCP/IP network, systems have IP addresses. Those IP addresses are the unique identification number for that system on that network. Part of the address identifies the network itself, and then the other part identifies the local computer or the host. The IP address consists of 4 sets of 8 binary numbers, octets separated by a single period. The octet numbers range from 0 to 255. Every LAN needs a default gateway. It's the way to talk to computers that are outside of your network. You need to go through the router in some form or fashion, and that is what the default gateway does for you. Routers are devices that have at least 2 IP addresses, one that connects the internal LAN, usually to a switch, and another that connects to the rest of the network, like the internet. The IP address of the LAN side of the router, the port connected to your LAN, is the address your computer needs to send data to anything outside of its own network ID. That is the default gateway. Next, we have DNS, the domain name service. It's not required, it just makes the internet extremely convenient. It's a method used to correlate IP addresses with more human-friendly designation. Understand that humans, we don't remember strings of numbers well. However, we do remember names. That's what DNS does for you. It's special computers that keep databases of IP addresses and then their corresponding names. So for instance, with domain names such as trueia.com is used in your internet browser, the computer queries the DNS server to get the correlating IP address for the text entry of trueia.com. So the internet has regulated domain names and domain qualifiers. We call those the top level domain names, or TLDs. You'll know them as .com or .edu or .gov. When configuring computers on the network, there are four primary pieces of information that you must have. You must have an IP address, a subnet mask, a default gateway, and at least one DNS server. Now, again, DNS isn't required. It's just a lot easier to find a web address. You don't have to constantly remember the IP addressing for it. Next, we'll talk about Domain Host Configuration Protocol, or DHCP. If DHCP is running on your network, your computer must be configured to obtain that IP address automatically. Again, this isn't required. It saves a lot of administrative headache if you don't have to manually configure every IP address, or we call that using static addressing. The DHCP server provides your computer with all the IP information that it needs to get on the network. Next, network organization. There are many different ways to organize your networks, starting with the most basic and simplistic of them, the work groups. By default, for every fresh Windows installation, it will name a work group. Every computer on the network needs the same workgroup name to be able to share resources. Now, you can use the default workgroup name, or you can easily change that. However, workgroups lack centralized control over the network. All systems connected to the network are equals. It works well for small networks because there are fewer users and connections and usually fewer security concerns. Another issue with workgroups is usernames and passwords are stored on the local computers. It's unique to that computer. It won't work on any other computer in the workgroup. So shared folders and files, you grant access based on the local computer's user accounts. So people logging in from another computer need a username and password for the local computer that they're logging into. So in a workgroup, you have three options to enable resource sharing. You can make people log on using another user account on the computer that has the shares. You can create the same accounts on every computer in the workgroup, or you can use one account for all computers. However, the larger these networks get and have gotten, work groups just became unrealistic. These larger networks needed a better solution. They need more control. That's why we use domains. Domains offer centralized security and control, unlike the work groups do. Domains require a specific server set, though, to control access to the network resources. But domains make it possible to track each user, each resource, and what each user can and cannot do with those resources. To set up a domain, requires special software. The most current versions would be Windows Server 2008 and Windows Server 2008 R2. Systems running Windows Server products are called domain controllers. User accounts are called domain accounts and reside on the domain controller instead of the local PCs. So the computers on the network must join the domain to be able to access the domain's shared resources. When logging on to a domain, Windows prompts for a username instead of showing all of the domain users on the network. That would probably be overwhelming. One of the key features of a domain is the ability to log on to any computer on the domain using the same domain credentials. We call that single sign-on. You no longer need to manage multiple or single accounts on local computers. With the introduction of Windows 7, Microsoft introduced a new term, or at least a new idea on an old idea. It's called the home groups. Home groups skip the folders and folder sharing. At its heart, it's centralized on the idea that people want to share data and not necessarily folders. So a home group connects a group of computers using a common password. There are no special usernames required. Each computer can be a member of only one home group, though. To make a home group, just open the home group control panel applet. You'll have 5 options. You'll have pictures, music, video, documents, and printers as your sharing options. All home group data is encrypted between the systems, so at least there's a level of security, again, that work groups didn't offer. There you have it. It's pretty simple. Remember, everything starts with the basics. Once you have these understood, everything gets a whole lot easier. If you have any questions or even just a comment, feel free to leave them below, and I do read each and every one of them. I'll see you next time.